So I'll have to be on my toes and get everything right. But, which is a bit hard after a couple of beers, but we'll cope. Anyway, so basically, you know, you will know therefore that RabbitMQ supports the AMQP protocol, or more specifically it supports up to 0.9.1 of the AMQP protocol natively, and it supports 1.0 via a plugin. But via the actual plugin mechanism that RabbitMQ supports, it's also capable of sustaining a number of other message queuing protocols. So what this talk is about is just really looking at, well, we'll cover a number of aspects. We'll talk about the history of AMQP and RabbitMQ. We'll talk about the multi-protocol nature of Rabbit and just look at some of those protocols that it supports very, very briefly. And, you know, because we're all sort of geeky people who like looking at code, there are a few little Erlang examples, and there's also some other evil languages like Python and some Ruby and that sort of nonsense. So we'll just kind of go through a whole pile of things like that. I'm lucky enough to have a good friend of mine, Eric Newcomer, with us today, and Eric was one of the founding members of the original AMQP committee, so he was kind of responsible for helping to define those initial standards and so forth. So I'll start off the presentation. I'll get to a point where I'll hand off to Eric and he can kind of talk about the history of the AMQP, the Advanced Message Queuing Protocol, and maybe just say a few words about message queuing in general and why it's sort of seems to be going through something of a resurgence, really. And then I'll jump back in and start talking about Rabbit in more detail and how it supports multiple message queuing protocols. But first up, just some background. You've read the blurb, which is why you're here, and there's, you know, a pretty picture of me looking windblown and husky in the wild souths of New Zealand, where I come from, which is the strange accent. I worked for Digital Equipment Corporation and Compaq and then Hewlett-Packard, so I worked for three companies and stayed in the same office. If you know your history, Digital Equipment Corporation was bought by Compaq, who in turn were bought by HP. I started my life in the computer industry working with an operating system called OpenVMS. Anyone here familiar with OpenVMS? Okay, I was going to say the older ones, but Barry, you're not quite that. You're just unfortunate. But, so anyway, OpenVMS was an operating system developed by Digital Equipment Corporation originally in 1977. And I left HP late last year and to work with a small startup company which has now actually licensed all the IP from HP to develop new versions of the OpenVMS operating system. We worked out, I can't really say the numbers, but we worked out essentially how much money HP was making out of OpenVMS, and it just was not enough for a corporation the size of HP to be a viable business. But they were very happy to spin it off and essentially license it to us to evolve that operating system going forward. So my role with VSI, as we're affectionately known, VMS Software Inc., my role with them is to really figure out our open source strategy and the sorts of technologies that we're going to, open source technologies we're going to make available on the platform. And given my involvement over the years with Erlang and things like that, that's fairly high on the list of one of the open source technologies we want to get on to the OpenVMS platform. And indeed, I have actually already done that port. It does work. And it will run things like Rabbit and React and Yours and so forth. So a lot of work to do. The little picture down there is a couple of good friends of mine. The shorter guy is Eddie, who's the guy who founded this company, VSI. And poor old Eddie is going through a state of culture shock because he comes from Mississippi and he's just had to move up to Massachusetts. And he was trying to convince me that the word dog actually contained two vowels, or two syllables I should say. And the chap talking to him was an English gentleman, another good friend of mine who I had dinner with last night, Ken, who is involved with OpenVMS in England here. And Ken won't be upset if I say it, but it's a fairly typical pose of him holding a wine glass. I won't bore you with the history of VMS, other than to say that Eric worked with it for many years, designing transaction processing systems and things like that. I don't think you'll talk too much about that, but has written books on those sorts of subjects, which are fairly closely aligned with message queuing, before moving into, well, web services and AMQP. So, just to outline the talk, as I say, we'll give a brief overview of AMQP and the history thereof, a bit of an overview of Rabbit, and then start getting into the more interesting stuff, talking about the plugin architecture within RabbitMQ and its ability to support multiple protocols simultaneously, and wrap up questions, more pizza and some beer, I guess. So at this point, I'll pretty much hand off to Eric to talk a little bit about the history of AMQP, but I'll just say a few words. I mean, those of you here who have used RabbitMQ are presumably reasonably familiar with the advanced message queuing protocol, the fact that it's an open protocol, and some of the key features of the protocol are listed there on the slide. One of the key things really, there have been many attempts over the years, I think, to define standards for these sorts of technologies. I worked back in the 90s with technologies such as DCE, and Eric worked a lot with Iona, with Corba. And the idea with some of these standards like DCE and Corba was that any vendor could go off and develop their own implementation, and say HP's implementation would work seamlessly with IBM's implementation, and so on and so forth. That never really succeeded. It kind of partially did, but not really. And what they did with AMQP was kind of take a slightly different approach and really look at it at the low level, nuts and bolts level, and really nut out what the wire protocol looked like more so than the APIs. If you look at things like DCE and Corba, the focus seemed very much around designing an API, although obviously it had to speak the same language under the hood. The emphasis with AMQP almost seemed to be more bottom up, actually, you know, as long as something can speak the right protocol in terms of how the bits and bytes are shaped if they go out over the wire, we don't really care what your API looks like as long as it sends the messages in the right format. So I'll let Eric jump in now and talk for a few minutes about the history of AMQP and how he came to be involved in the working group and so forth, just going back to the early days back in the 2000s.
All right, thanks Brett, and thanks for including me in the talk tonight. Thanks everybody for coming. AMQP, I think, as Brett was getting to, was originally intended to create a wire format standard for JMS or for messaging, and eventually it became something where it was trying to define the whole car, as they talked about in some of the later meetings, trying to replace all of MQ instead of just being a wire format protocol. One of the challenges in the messaging area, at the time AMQP came out in 2004, we had the JMS spec, which was an API spec. We didn't have a wire protocol, so unlike Corba, DCE, some of these other distributed computing mechanisms that had both an API and a standard protocol, JMS had only the API and not a standard protocol. So our initial thought was AMQP is going to fill a very important gap in the standards community. And I was working at Iona at the time. We're a very standards-oriented company. I often talk about Iona as one of the only companies I know that really made a lot of money on the Corba spec. That's another story. When I was at Digital, I saw the other side of it, where we were investing in Corba at the time I was there and unable to compete with Iona, which surprised a lot of people. A small Irish company could really capture the Corba market away from the giant computer companies as Digital, HP, IBM, Sun, and so on, but they did. That's kind of another story. But the Corba and DCE before it, for distributed computing protocols, did focus on the API and the protocols and the interoperability. JMS had only got the API. We needed the wire format for the interoperability, and that's what AMQP promised, and that's why we signed up for it. JP Morgan approached us very early on. We were one of the first vendors to sign on to the AMQP spec and support it. A colleague of mine named Carl Treloff, who went off to Red Hat and later took the AMQP idea with him, and I can't remember the name of the messaging protocol at Red Hat now. Maybe you, Dara, do you remember this one, the C++ protocol at Red Hat?
Cupid.
Cupid, thank you. So Cupid was spun out of this by Carl, who was originally at Iona and involved in the beginning of AMQP. And the reason I mentioned his name is we were involved in the SCA specification at the time. I don't know how many of you remember this. Service component architecture. IBM was positioning it as the next Java EE at the time. This was going to be kind of the runtime spec for web services, where web services have the APIs and the XML format, but how does that get executed? How do you take the abstract interface and message definitions and create executable software out of them? That was supposedly the SCA space, and that didn't work out for a lot of reasons, but Carl actually took the legal paperwork from SCA, and IBM approached us about SCA at Iona because we had started, funny thing is that we had started an SOA project at Eclipse, and IBM came to us and said, we were going to do that, but you did it first, so therefore you have to join SCA. as a founding member, which was also kind of funny for another small company from Ireland, but still interesting because we did participate and we did try to fix the SCA spec. We weren't able to because IBM had already been down the implementation path with it too far, and again, another story. But the legal paperwork that we had from the SCA consortium was actually used to found the AMQP consortium. Kind of a strange coincidence, and it was one of these binding intellectual property agreements that later on would become significant when, for example, I personally talked with people from AT&T to recruit them into the effort, and this became a problem because of their patent portfolio, and we were unable to overcome that with the paperwork. Otherwise, with AT&T's participation, AMQP's success or adoption industry could have been different than it was today. But one of the main challenges that evolved in AMQP was that AMQP scope, as I mentioned earlier, started to grow from just a wire format protocol for interoperability into let's define an open source standard for all of MQ series. Let's replace MQ series with an open standard, and this was the incongruity or the incompatibility between 0.9 spec and 0.1 spec, which was kind of the hurdle over which AMQP was unable to really jump to become ubiquitous. It's had some level of success, but to become completely widely adopted by IBM, Microsoft, Oracle. Of course, we spoke with those companies many times about it, and typically they would have reacted to it as it was kind of put to them as, we're trying to, or IBM, we're trying to put you out of business here, why don't you sign on to our spec? Okay, great, let's do that, let's help put ourselves out of business. So I think once that scope increased a bit more, the adoption level decreased because the burden of implementation became higher and the challenge to incumbents also increased. But there was an interesting working group, and interestingly enough for me, I went from Iona into Credit Suisse, in part because Iona was a big supplier to Credit Suisse. Iona was acquired by Progress. I was out of a job, and the Credit Suisse guy said, why don't you join us in New York, which is how I got into banking. And at Citigroup now, and I don't know how to get out of banking. If anybody knows how to do that, please talk to me afterwards. But it's not all bad. It's very interesting. Where I am now, we do about $5 to $7 trillion a day worldwide funds transfers through Citibank. So it's kind of interesting scale of problem from computing. But Credit Suisse was also a member, again because of the Iona connection, of AMQP at that time. So I ended up being the manager of the participant in AMQP once I got to Credit Suisse, and we did try very hard to bring it in. We were actually very interested in it, but we couldn't really find the sort of the critical mass of adoption to bring it in a good commercial way. So that's a little bit of the background there on it. I kind of would sum it up as a very good idea for the initial scope. It kind of, because the scope got too ambitious or too broad, kind of failed really to achieve the level of adoption that it might have if the scope had maintained more narrowly and then built up from there. The whole standards process is something that could also be another separate conversation, but it's very important to have something that fits a need, fits a business purpose, somebody that finds it useful, and to be able to get consensus around the companies that are going to implement it. And once you get into a broader scope, you have more challenges in those areas. So I think in some ways AMQP had a good initial foundation, good initial success, but then taking the next step became a little bit more challenging. So this is kind of a history of message queuing. I don't know we'll spend much time on this. I'll maybe say a couple of words and turn it back over to Brett. It's good fortune to work with Brett at Digital for many years. And those of you who remember the company may remember it as a great technology leader at the time, #2 computer company in the world at the time, and did a lot of innovation, including messaging. We had DecMessageQ, it was a very successful messaging product.
Version 3.1, not your best.
Sorry?
Version 3.1 wasn't the best for you.
Well, I was never on, I was on the transaction processing product. I was on the ACMS product, which is an RPC-based TP monitor. It was RPC-based in 1984. It had a structured 3-tier model that later became popular in app servers. had an interface definition model, structured definition language, all of these things back in '84 that later become popularized in app servers. And at the time, we were thinking, why does anybody need messaging? Because you've got all this great stuff with RPC, and the thinking and research and academia and engineering was RPC is the most modern, the most advanced way to do distributed computing. And we would run into the deck messaging guys and we'd say, what are you guys doing? This is asynchronous stuff, it's broken, it's hard to program, it's visible in the code, we can abstract everything away with RPC, it's like procedure call, very easy programming model. But what? You guys know, really, you need both paradigms. And as Brett was saying earlier, even though a lot of the initial distributed computing came out of what I would call the mainframe concept of everything being under very tight control. I've got control of my app, control of my users, control of my environment, all my resources. If I need to do a connection-oriented protocol, which is what all the early communications were, look at the early LU62 communications from IBM, which really started the distributed computing concept and implementations, LU62, distributed transactions, distributed two-phase commit, all of that comes out of there. And certainly at digital, in the mini-computer era, what we were trying to do was compete with IBM and get some of those applications off the mainframe onto the mini-computers, and to do so we had to replicate their qualities of service, including the distributed transactions, the reliability, security. You see the same phenomenon through DCE, through Corba, through Windows. All of these distributed computing qualities of service really were trying to replicate what the mainframe had in the distributed environment to get the applications off of there, or at least participate in the application ecosystem as kind of an equal partner. But on the other hand, we had this other computing trend coming up from the web, which by explicit design excluded session-oriented protocols. All these other protocols, all these other communication mechanisms I've been talking about relied on a shared session state between communicating parties. But that's an expensive resource that on the web you couldn't afford. And today we're seeing much more of a recognition of the value of stateless communication, of stateless protocols, of stateless applications, and the role of messaging is therefore starting to increase again. Asynchronous messaging coming really back into the fore in cloud computing, commodity data center architectures, big data, all these environments, RESTful communications, which are really starting to become much more popular. So in the early days, we would have thought of connection-oriented protocols as the way to go because it simplified programming, allowed you to do updates in place across distributed environments. But the cost of that in modern environments, which need to be much more scalable, much more flexible, is just too high. We're seeing the resurgence of asynchronous messaging. Well, Brett,
cool.
Back to you.
Thank you, Eric. Alrighty. So Eric just made his notes. He was sitting over there for about 2 minutes and scrolled down some notes, and he managed to talk for 15 minutes.
Sorry, I only meant to take 5.
That's all right. That's not a problem. Just a little bit more background on the advanced message queuing protocol, and that in a reasonably significant part, it was kind of born of frustration. So you had John O'Hara, who's the father of AMQP, the guy that came up with the whole idea originally at JP Morgan Chase, where, like every project he did, every integration project he did, they'd go out and they'd buy some new middleware technology, and that wasn't compatible, it didn't speak properly with these other middleware technologies they had, and they'd have to develop some bespoke gateway, and they'd then have to also pay license fees for that other middleware product. They'd have to have a team that knew how to support that other product and also how to support the bespoke gateways that they developed. And it just became a pile of spaghetti and a huge integration nightmare. So the whole concept of AMQP, John thought there must be a better way of doing this, we must be able to improve on this situation, and he came up with the whole notion of AMQP, engaged some, did some hard work to engage some fairly significant players, Iona, and latterly Microsoft and IBM and so forth are now all involved in one way or another. As Eric said, basically AMQP started off with take on somewhat larger aspirations. And I think, you know, the little bit that I've got down there, I mean, John, I think, always had some fairly big ideas, Eric, would that be fair to say?
He wanted to get rid of MQ.
Indeed, indeed. So, you know, from its inception, from John O'Hara's perspective, he had, you know, a view of world domination as far as message queuing was concerned, that AMQP was going to be it, that you could displace MQ series, that you could displace NSMQ, TIBCO, whatever else you might have in your enterprise, you could use AMQP and it would solve all your message queuing and integration problems. Something that was going to be usable from any language, any integration pattern that you might have in mind, any sort of data payload that you need to send around, any platform that it would be reliable, interoperable, manageable, performance scalable, all those fancy words. So not a chap that liked to sort of think small about these things. The original notion, and I just point out here that the box over to my right, I guess down the bottom there, that what I'm talking about here, and indeed for most of this talk, I'm talking about AMQP 0.9.1 as opposed to AMQP 1.0. So as I said before, Rabbit natively supports 9.1, supports version 1 via, which is a ratified standard, supports version 1 via a plugin. Most people that use Rabbit probably don't particularly care what the underlying protocol is. They just like the programming model, they like the fact that it works well, that it's flexible, scalable and so forth. But it's kind of useful to understand some of the background. But from an AMQP 0.9.1 model, basically what you're looking at with RabbitMQ and similar such product, Cupid for example, is the following key components. You've got the message layer, which consists of exchanges, queues and bindings. So, you know, exchanges and queues, well, queues are fairly self-explanatory. Most people know what a queue is. The way an exchange works, it's kind of like a software switch. You publish a message to an exchange, you do not publish a message to a queue. You publish a message to an exchange, the exchange knows how to route that message into 0 or more queues based on binding information. So the bindings basically set up how the queues are connected to the exchanges. But you publish to an exchange, exchanges route messages into queues, and consumers consume messages from queues. We talked about the wire protocol before, and all of this stuff is broker based, okay? So you've got a message broker, you're publishing your messages to a broker, you're consuming messages from that broker. Now, whilst John O'Hara worked in the banking sector, which, you know, will push through millions, billions of transactions potentially a day, he wanted something that was going to be usable by essentially anyone, someone developing that application in their garage, up to somebody who's doing the sort of work that John was doing with market data and so forth, and JP Morgan Chase pushing through trillions of dollars worth of transactions daily. So he wanted AMQP to be, not only do lots of fantastic stuff, but also be available to everybody to use to do that fantastic stuff. What I'm going to talk about next is just some of the core functionality that you'll find within these AMQP implementations, and obviously the focus is on Rabbit. I talked about exchanges before. Now, exchanges can be of different types, and that depends on the type of messaging pattern that you're trying to achieve, how you want your messages to be routed between the publisher and the consumer. So the standard exchange types within Rabbit or Cupid, for example, are direct exchanges and fan-out and topic exchanges. So direct exchange is kind of a point-to-point scenario where publisher publishes a message and that message is consumed by one and only one consumer. Okay, so that message is routed by the exchange into one queue and that message is read off the queue by one consumer. You may have multiple consumers hanging off of that queue, and most implementations will do something like round robin to load balance between those consumers. But the bottom line is, it's one message is published in, one consumer will end up consuming that message and doing some work with it. Fan-out exchange. In the case of a fan-out exchange, we're then starting to look at a publish-subscribe mechanism where you could have potentially, in this case, multiple queues, in this case 3 queues bound to an exchange. Publisher publishes a message, the exchange will route that message into, the publisher publishes a message into a fan-out exchange. Any queue that is bound to that fan-out exchange will get a copy of the message. So in this case, all of queues 1, 2 and 3 are getting all of the messages in 1, 2 and 3, and you might have one or more consumers hanging off the end of those exchanges. But there's no filtering going on. There's no filtering to say, well, queue number 1's only going to get message number 2 and queue number 3's only going to get message number 1 or something like that. It's every queue that is bound to the FANET exchange will get a copy of the message. More sophisticated approach is the so-called topic exchange, where there's some regular expression matching going on via the binding patterns and so forth. So our publisher is going to publish a message to the topic exchange, and depending on information within that message, the message may be routed into 0 or more queues based on the binding information available there. Okay. So content-based routing. Something that I think is, is probably kind of common in the financial sector. Yeah.
Absolutely.
Okay, so that's just a very sort of brief overview, and Eric's given some background on the history of the Advanced Message Queuing Protocol, and just a brief overview of some key aspects of the protocol and how it all works. Now just getting on to some more specifics around Rabbit. And I'll give thanks to Alexis Richardson, who formerly of RabbitMQ, for some of these slides, including the cute little bunny here. So Rabbit, as many of you know, is a 100% Erlang implementation of AMQP. It's arguably, I think, well, probably not all that arguably, almost without question, the most popular AMQP implementation. Very, very widely used. I think I mentioned in the abstract for the talk something like 35,000 plus production implementations, and these things are running, business critical systems all around the globe, anywhere from pizza ordering systems through to the other example I gave of being the central nervous system to an OpenStack clouds. Okay, so Rabbit is very, very widely used, very, very popular. It's a good piece of open source software. But as I say, it is 100% Erlang. I would say probably the only slight deviations from that are if you go and have a look through the Erlang code, you will find some OS command calls where it's going off and doing df commands and various things like that to check on disk space and so on and so forth. And I've had discussions with the developers about doing that in a somewhat more platform independent way, but to all extents and purposes, it is 100% Erlang. So AMQP broker. But what we'll talk about soon is its ability to support other protocols via a fairly sophisticated plugin mechanism, in no small part thanks to the capabilities of Erlang. There are clients available for Rabbit in, pick a language, think of a language, and there's probably a client available for it. And if you think of a language for which there isn't a client, then probably by tomorrow there will be one. Very brief history of Rabbit. So Rabbit was pretty much the second implementation of the evolving AMQP standard. The first implementation was done by Imatics. So John O'Hara at JP Chase engaged a small Belgian company called Imatics, the founder of which is a very entertaining chap who many of you probably know, Peter Hitchens. So Peter worked closely with JP Chase, and they developed the first AMQP implementation. The guys at Rabbit Technologies, Alexis Richardson and a few others, were very close behind, and they were pretty much the second cab off the rank as far as AMQP implementations were concerned. Starting off at around 2006. In 2010 I actually had a call with the Rabbit guys that particular morning, and there was much fun and hilarity, and it was very hard to have a conversation with them because they just managed to get themselves acquired by VMware and were feeling very happy with themselves. Around about April 2013, as some of you know, VMware and EMC spun out a company, Pivotal, which included a number of their cloud-based products, I suppose, in that set with things like Redis and RabbitMQ and Cloud Foundry and things like that. Spun them out as a separate entity. The little graphic over the side there is just a little Google query that it's probably not a valid comparison between some of the products there, but I don't think you can kind of question too much the rise in popularity of Rabbit as time is going on. I mean, it's heavily adopted, very popular piece of software. And the guys are also good because you can get hoodies and t-shirts from them. I was talking to Eric earlier today. some of the guys that originally created Rabbit are now doing a thing called Weave, which is like a networking technology for Docker. But one of the things that they've done consistently well in all of their entrepreneurial endeavours is they haven't sort of fallen into that trap where a lot of good open source software, you've got a good piece of open source software, but the documentation is poor, the management tools are poor, and things like that. Even if the core is good, if you want a serious business, if you want an enterprise customer to actually use your software, you need that operational stuff. You need the documentation, the monitoring and management, and so on and so forth. One thing the Rabbit guys did very, very well was to address those sorts of things and provide t-shirts. So they leveraged, which are also important because you get a lot of good marks for having top quality merch with your product. But they also did a really good job of leveraging the capabilities of Erlang. So I think Erlang is actually quite an inspired choice for the creation of Rabbit, because if you look at, say, something like OpenAMQ, which was the first version, first implementation of AMQP, it's several 100,000 lines of nasty, evil-looking C code. And Peter Hitchens wrote some tool that actually kind of generated most of it based on an XML implementation of the AMQP spec. But irrespective, it's a fairly substantial code base. If you look at Rabbit, it's probably about, I think when I last looked, 60,000 lines of Erlang code or whatever, with actually quite substantial commenting in it as well. So what they've done is they've actually leveraged many of the capabilities that come out of the box courtesy of Erlang to provide a very, very nice, concise piece of software that does all this good messaging stuff. And also leveraging the capabilities of Erlang around things like clustering and high availability, and indeed, to a lesser extent, monitoring. Erlang can't help the t-shirts, but it does its best. So courtesy of Erlang with Rabbit, as of, I don't know, probably about 2012 timeframe, they got the clustering side of things working fairly well. Clustering is fairly seamless within RabbitMQ. I've probably had a cluster up to about 30 or 40 nodes just playing around, but arguably there's no theoretical limit to how far you would go if you really want to. Clustering doesn't necessarily provide you with any significant performance benefits, but it does help to some degree with scalability and fault tolerance. Obviously with clustering you end up with chatter between the nodes, which can incur a time penalty and so forth. But it can be very good from a scalability and fault tolerance perspective, and you can add additional nodes into your cluster at any time or take them out at any time. But the key point to note, courtesy of Erlang, is it doesn't matter if a publisher publishes a message into, say, node number 1, consumer can consume that from any other node. It doesn't have to consume a message from the same node from which it was published into. Queues are essentially owned by one node and will reside on one node, but there is cluster-wide visibility of all those queues and exchanges and other such resources. A little bit later on, the guys added into the mix high availability with queue replication. And originally queue replication, the way in which you would specify replication is a little crude. Current implementations of Rabbit allow you to specify replication policies based on some sort of regular expression or whatever. Which is kind of nice. So if your primary, as I said before, a queue nominally lives on just one node within the Rabbit cluster, you could set that up so that that queue is replicated to another node or potentially multiple other nodes. It's up to you how you design it. Generally not a good idea to have your queue being replicated to every node in your cluster because that will probably incur significant performance overhead. But the bottom line is if that primary node goes down, then one of those secondary nodes can actually pick up the job and will take over the role of being the primary as far as the ownership of that queue is concerned. I should point out that queues within Rabbit or indeed any other AMQP implementation can be either durable or non-durable. You can still replicate non-durable queues, but there's arguably not such a good reason for doing that. Like I said before, any good piece of software that you want to be able to promote into large enterprise level customers, they want good documentation, they want good tools for monitoring what's going on and managing what's going on. The Rabbit guys actually did a really nice job around developing an API-based approach for doing the monitoring and management of Rabbit in a RESTful kind of fashion. They developed a web GUI that can use that API. There's also a command line tool, the RabbitMQ admin tool that you can use, which is written in Python. Or you can hook into the API any which way you like, anything from simple curl commands through to writing your own tools or whatever. You can call into that RESTful API to do management functions. But the web interface is generally speaking pretty darn useful for most purposes, and also good where you've got people on your team who maybe you don't necessarily want them getting in there and doing anything too drastic, but for people on your team can fairly quickly look at what's going on and understand it and rationalise it and know when bad stuff is happening. You know, like these little boxes, like if you're about to run out of socket descriptors, the boxes are not green, they are red. So quite an intuitive and easy to use interface. And of course it's all Erlang, and in the case of this it's not using Cowboy, what's the other? Moshi yeah. Security is obviously fairly important, so I think this is really part of the AMQP definition anyway, but within Rabbit or Cupid or other examples, other such products, there are different layers of security. At the top level, obviously you log in, you specify a username and a password, but you also have to specify something called a virtual host, a vhost. So the first layer of security is validating your username password vhost combination. Vhosts are kind of like little mini Rabbit implementations that run within the bigger Rabbit, and they're self-contained, and resources are unique to a vhost. So you could have an exchange called Fred within one vhost, you could have an exchange called Fred within another vhost. They are not the same exchange. So the vhost kind of acts, I suppose, a bit like a namespace in that sense. But anyway, assuming that you have actually validated, username, password, vhost checks out all right, you then fall through to saying, well, what can that person actually do now that they are logged into this vhost? And Rabbit implements kind of three types of operations here: configure, write, and read operations on a resource. So resource is things like an exchange or a queue or whatever. So you can write to an exchange, possibly, could be, you might be allowed to do that or you might not. You can read from a queue, yes or no. You can configure Rabbit. An example there would be defining the binding between a queue and an exchange. The way in which those permissions are defined is based on regular expressions. So it's not kind of 100% granular, and you do actually have to have a bit of a think about how you want to set up your permission structure, thinking in terms of how you define those regular expressions, but it's quite flexible. Brief summary of some of the other implementations. As I said before, Peter Hitchens and Martin Sustruck and a few others developed the very first AMQP implementation with openamq.org. At some point, I can't remember exactly what year, but at some point Omatics pulled out of the AMQP working group and no longer supported OpenAMQ. And Peter has gone on to work more with ZeroMQ and done fairly well out of that. We mentioned Cupid before with regards to Red Hat. There are also some people who are actually offering services, so StormMQ and Cloud AMQP. Cloud AMQP is basically Rabbit as a service. There are also, I mentioned before, how companies like IBM and Microsoft are starting to get into the mix with the advanced message queuing protocol. And even things like Apache ActiveMQ supports AMQP 1.0. Microsoft Azure similarly, and also IBM are working on a product, I think it's in beta at the moment, a thing called MQ Lite, which supports the AMQP 1.0 standard. So now just getting on to plugins and why they're important and why you should care and things like that. Plugins really are a key component of RabbitMQ. It's a relatively small kernel, and it's designed to be readily extensible through the implementation of plugins. Why would you implement plugins? Well, they allow you to do all sorts of cool stuff, and it's a good excuse to actually sit down and write some Erlang code. Key reasons why you would implement a plugin: perhaps you want to support some other sort of message queuing protocol, leveraging the capabilities, the core capabilities that Rabbit provides that we've talked about previously: clustering, security, scalability, fault tolerance, all that sort of stuff. What you tend to find, and I'll talk about it a little bit more later on, is that these message queuing protocols like STOMP and MQTT and so forth, They all have quite a lot of characteristics in common, and indeed if you have any familiarity with MQ series and you go and have a look at AMQP 0.9.1, it almost looks like the guys picked up some of the features of MQ series and incorporated them into the way that AMQP works. So adding support for additional messaging protocols is one reason why you might write a plugin. Alternative authentication mechanisms. So for example, when I was working with HP's cloud team, we implemented, I implemented a plugin that allows you to authenticate against OpenStack Keystone, which is the identity management system within OpenStack. You can write plugins that will do alternative authentication mechanisms. Different messaging stores. So when you do persistent or durable messaging with RabbitMQ, it doesn't use amnesia for that. This is a common misunderstanding. Rabbit doesn't use amnesia for storing messages. The Rabbit team actually spent a heck of a lot of time designing a very efficient mechanism for storing messages, for persisting messages to disk, but it does not use amnesia. You can, however, write plugins to implement alternative messaging stores. I know, for example, one of the guys implemented something that used TokyoDB, for example. You can do that. Extending the functionality of the broker, a few examples there. We looked before at the management plugin and so forth. Message tracing, things like Shovel and Federation. Shovel allows you to set up a system whereby messages are essentially shoveled from one queue into another, and Federation allows you to sort of set up a whole tree of brokers and move messages through that tree to potentially increase scalability and things like that. New exchange types. Actually, developing a new exchange type is relatively straightforward and doesn't require too much code. It tends to require more imagination. So remember, exchanges are those things that you publish messages to, and the exchange determines how the messages get routed, whether it's direct into one queue, whether it's fan out or topic. So you can implement your own custom exchange if you have some particular requirement in terms of how you want your messages routed. The React exchange, for example, what that does for every message that gets published into an exchange, it saves a copy off into a React database. You might want to save copies of all your messages, for example, and that's a reasonably efficient way of doing it. The sharding exchange is kind of cool, where messages, you're partitioning messages across sharded queues. As I say, writing custom exchanges is actually relatively straightforward. It tends to be more, what's the scenario you're trying to address. So I think we've pretty much covered why write a plugin. You want to do some stuff that Rabbit doesn't do out of the box. Key points to note, I suppose, that these plugins do run within the broker. So if you write bad code or whatever, you could potentially crash the whole shooting match, although Erlang's reasonably tolerant of reasonable levels of stupidity. Being able to have plugins like that fit in with Rabbit also allows you to bundle things up and have a single installable product, as opposed to sort of having to install one thing and then install others. And what it then comes down to is just enabling and disabling the plugins that you're interested in. So simple command line, RabbitMQ plugin enable Rabbit management, for example. Very simple to enable and disable plugins. And newer versions of RabbitMQ actually allow you to do that on the fly. Older versions you had to actually cycle the broker to pick up configuration changes in terms of plugins. Newer versions not so. Some comments on writing plugins. The RabbitMQ team provide a kind of umbrella that you can work with, provides the basic shell to get you started on writing plugins. I don't like it. I'm probably just stupid or something, and it's never worked well for me. I've kind of stolen some other bits and pieces from the community and tend to use a rebar-based build mechanism for building plugins, which to my mind is a lot less painful and irritating and works very seamlessly. And I would like to thank the Basho guys for inventing rebar. If you are writing a plugin, you generally have to have a pretty darn good knowledge of RabbitMQ and the internals thereof. Maybe less so these days, but certainly in the early days, before some of the APIs had settled down, you used to find that you'd have some plugin that worked really well, new version of Rabbit would come out, and everything would kind of explode in front of you, and you'd get very nice, fascinating looking Erlang stack traces appearing in the log files. Rabbit is now very mature. There are very few changes in terms of those internal APIs from one version to the next. So, you know, the fear of plugins breaking from one version of Rabbit to the next is now virtually nil. I mean, that's not to say that you obviously, if you do have a plugin and customers are using it, you obviously need to qualify and test it with any new version of Rabbit that might come out. I'm not sure how long I want to dwell on this because I think there's still pizza left and there's certainly beer. But one of the interesting things that was implemented, I should point out, so I'm from New Zealand and two of the original developers on RabbitMQ are also from New Zealand. One of them, a very clever chap, Tony Garmick-Jones, who's now somewhere over Boston way doing a PhD. But what Tony identified when they were implementing Rabbit in the early days was that it's a fairly complex piece of work, and they knew from the early days that it was going to be extensible via these plugins, and different plugins have different dependencies and can't really start up until certain other things within Rabbit have started up and so forth. So Tony came up with this concept of boot steps, basically which are, you know, special little tags that you slip into the Erlang modules, and when Rabbit starts up it builds up a tree of what all the dependencies and so on and so forth are, based on what plugins are there and what other bits and pieces are there, and it ensures that everything gets started in a coherent fashion. So you as a developer don't have to worry too much about it. You just have to say, if you've got a particular plugin, well, this plugin I know it can't start until this certain thing started over here, so you define a boot step to cover that. So I don't think I'll go through it in too much detail, but this is an example of, in this case, what's called the recovery boot step. So when Rabbit starts up, assuming it's not the first time it started, it actually wants to go through and check that everything looks okay. So it wants to check that the amnesia database, which is used to store configuration information, it wants to make sure that's not corrupt, and if it is, it might need to do some fixing. It wants to make sure that any files on disk containing swapped out messages, durable messages, that all of that stuff looks consistent and so forth. So one of the first things it does when it starts up is do like a recovery step to make sure everything looks clean and is good before it can move forward with the rest of the boot sequence. So that's the recovery boot step, and it's going to do a few other things, and once that's completed it's going to say that, okay, this routing ready boot step can then run. And once the routing ready boot step runs, well, routing can happen, routing being routing messages from exchanges into queues. I'm not going to go through too much more of this because it gets a bit tedious, but boot steps are important, and as indeed is my boot collection. But probably the key point, as I say, these things are very important from a plugin perspective. It makes it easier for you to write plugins and ensure that things get started up properly. Tony, as I say, who implemented this, is becoming a bit of an academic, and he likes fancy terms like directed acyclic graphs. And I don't know how many of you have read Alvaro's book, RabbitMQ in Action. So Alvaro rather painstakingly went through and had a detailed look at Rabbit and how all the boot steps hang together, and came up with this rather impressive looking diagram which is almost illegible. But this basically illustrates the boot sequence within Rabbit for a fairly standard implementation. Bottom line is, booting up any sort of substantial Erlang application like this is not a trivial task. The boot steps approach that Tony came up with makes it a lot cleaner, simpler and easier, and also accommodates the fact that people do want to write plugins and extend the broker and don't want to have to worry too much about all this nonsense or understand it in order for things to work. Alvaro's posted some stuff on the web, he's written a blog about all of this, there's a lot of detail. So finally getting on to the whole multi-protocol open source messaging hub thing. It was something I started looking at a few years ago, really. These different message queuing protocols, AMQP, MQTT, STOMP and so forth, they have a lot of characteristics in common, but they also have particular use cases that they're better suited to than others. And you know, one of the nice things about Rabbit and its multi-protocol support, for example, is that you could publish a message into Rabbit using one protocol, and you could consume that message via a different protocol, or potentially you could consume it simultaneously via several different protocols. It doesn't matter. What I should say though is that this ability is not necessarily unique to Rabbit. What I would say is Rabbit was probably one of the first to do it nicely, but even other queuing products, Java-based technologies such as ActiveMQ, for example, now do actually support similar such multi-protocol technologies, but I don't think they do it quite as nicely. Actually, I think that's the photo you sent me, Eric.
Was there beer in it?
Yeah, there's beer in it. Yeah. I think this was Eric was kind of quite surprised that there were all these New Zealand beers for sale in New York, and thought he'd send me a picture of it.
It's amazing.
Yeah. And I just needed something to fill some space on the slide. So, you know, like I say, well, cool, fine and dandy, so we can support all these protocols, but why should I really care? Well, like I say, the whole notion of one message queuing protocol being able to sort of do everything is kind of fundamentally flawed. Eric talked a bit about that, where you kind of end up unnecessarily bloating things. It's just, they're all of these protocols have slightly different characteristics. Yes, they have a lot in common, but they have slightly different characteristics that make them better suited to certain scenarios than others. So some protocols, as I've said here, are optimized for low latency transmission of small messages, really good for that. Other protocols might be designed more for efficient transmission of large messages. Okay. Some protocols will sacrifice performance for reliability. So if you look at like a stock exchange type example, you've got two interesting but quite different use cases that go on there. There will be literally millions of quotes just flying around all over the place, you know, in microsecond timescales. If one or other of those quotes gets dropped, the bank or the exchange doesn't really care because there's another one going to come along in a few microseconds, that's fine. But when someone actually buys something and a transaction has to occur, you know, that has to happen a little bit more slowly and reliably. Right? People don't like losing money. Dropping quotes is one thing, so that's, you know, that's low latency transmission of small messages. But when people are actually exchanging real money, that has to be done reliably. And as soon as you include the word reliable in the sentence, you also incur a time penalty. Okay? So not all protocols are created equal. And, you know, like I said down the bottom here, any attempt to accommodate all possible messaging scenarios within the scope of a single protocol must entail some level of compromise. Now, John O'Hara had, you know, great designs for AMQP to be able to do everything. It doesn't quite do everything. It covers most scenarios, but, you know, there are other protocols that are better suited to specific use cases. Another reason for having multi-protocol support, or being able to support the ability to facilitate different protocols, is adaptability. Right? You know, what seemed like a good idea in the IT industry today might not necessarily be such a good idea tomorrow. I mean, I've seen, I don't know how many technologies come and go that seemed like really good ideas at the time. You give it a few years, you give it a decade, and after all the Gartner hype's sort of gone down and you're on the other side of the hype curve and so forth, something else is coming along. So technologies need to be able to adapt, otherwise they cease to exist. So with something like Rabbit, you've got a good solid core. You can implement other stuff around it that leverages that core to implement these different protocols. So some of the protocols that are supported by Rabbit via plugins today, STOMP, and I'll talk a little bit about some of these shortly. MQTT, which is kind of becoming one of the preferred protocols for the Internet of Things that Dara could probably comment on as to whether he likes it or not. ZeroMQ, there hasn't been too much work on ZeroMQ plugin in recent times, but it's still there. Sort of RESTful messaging, I must admit the idea of message queuing and HTTP is a combination that doesn't gel well with me, but there's kind of a cute plugin called RabbitHub, which I've done quite a bit of work with, that allows you to do that to some degree, and, you know, WebSockets and various others. So just, you know, for people who may or may not be familiar with some of these protocols, so STOMP is the simple or streaming text-oriented messaging protocol. You know, you could whip up a STOMP client in your favourite language probably within an hour or so. It's not a sophisticated protocol. And as its name suggests, the keyword is text. So you're dealing with essentially textual messages. We're not talking about arbitrary blobs of data here. One point that I did make there is the actual model around STOMP. It maps quite well to the AMQP 0.9.1 model. MQTT, so as I said, if you look at the Internet of Things, well, probably a good example of MQTT would be Facebook Messenger, which uses the MQTT protocol. You think on your phones, how many times your phone is polling a web server or another to see whether you've got some new email or something like that, or some new content. All of that polling is, inefficient. It wastes a huge amount of time. It wastes a huge amount of energy. Protocols like MQTT are designed to be very lightweight and efficient, and for use on things like sensors and so forth, and in relatively constrained network environments. Okay, so this would be an example of MQTT. It does have different quality of service levels, but at the lowest quality of service level, there are inherent risks that you're going to drop messages, and that's a decision that you have made that is acceptable. One of the guys that invented MQTT, Andy Stanford Clark, I should say, lives off one of those islands off the UK. Well, I can't remember which one.
Isle of Wight, isn't it?
Yeah, he is. He's on the Isle of Wight. That's right. But he's quite an entertaining guy, and he's kind of got just about everything in his house is monitored via MQTT. So wherever Andy's giving a talk in the world, he can go, oh hell, I forgot to water my pot plants, because he's got sensors stuck in the pot plants that are monitoring water content, things like that. Whatever turns you on. Personally, my pot plants just die, but there you go.
That's not potted cannabis, right? That's potted plant. Who knows?
But
You just need more MQTT.
well, yeah, well, that's right. It's a nice protocol, very lightweight, very easy to use, very simple to understand. I mean, that's a key selling point to me, simple to understand. And again, it's something that maps quite well, I would say in this case, to a subset of AMQP. The RabbitHub plugin, as I say, this was actually another invention of Tony Garnett-Jones. And it, as the first few points there, it basically allows you to do messaging using HTTP and mapping things to RabbitMQ exchanges and queues. So it gives every exchange and queue hosted by the broker two URLs, one for delivering messages into an exchange or a queue, and one to use to subscribe for messages. So it's a webhook-based mechanism. So when you subscribe to a particular queue or whatever, part of the subscription is you specify a webhook, a callback URL, and RabbitHub will push any messages out to that nominated URL. It's an implementation of this funny thing, the pub-sub-hub protocol. The only redeeming feature of that is not its name, but the fact that one of the people that devised it has the Christian name of Brett. So that's got to be a positive from my perspective. So just for example, subscribing to a feed with RabbitHub, just to illustrate what I was talking about here. So in this case, we're going to subscribe any messages that get published into the exchange AMQ.direct, which is one of the default built-in direct exchanges with the routing key of foo, are going to be forwarded by RabbitHub to the nominated URL. And we've specified an expiry time of this command of 600 seconds, which is arguably not a terribly useful period of time for subscribing to messages, but it serves to illustrate the point. So this particular command would send a subscription request into RabbitHub, the web server for RabbitHub running within Rabbit, listening on port 15670 to establish that subscription. So what RabbitHub does is it actually adds another couple of tables to the Amnesia configuration database used by Rabbit to store the subscription information and so forth. And a key point down the bottom here, like I said before, Rabbit doesn't care how a message is published or how it's consumed. So it doesn't particularly care if your publisher is one protocol and your consumer is another. It's largely irrelevant. It's just the routing mechanism, it's the delivery mechanism. I often make a sort of a kind of a comment that one of the good things about standards is there's a lot of them, but key thing about these protocols that are supported by Rabbit is that they are open standards, which has got to be a good thing. And remember that one of the key motivations behind AMQP in the first place, from John O'Hara's perspective, was to escape that middleware hell. Now you might think, well, hang on, but these plugins are supporting different protocols and things like that. Haven't we still kind of got some of that hellish behaviour going on? Well, I put a little box down here in yellow, which hopefully kind of suggests not, right? I mean, in my view, anyway, there's kind of a fairly major difference between developing gateways and adapters to bridge proprietary protocols than having some sort of technology like Rabbit that can readily be extended to facilitate this sort of multi-protocol messaging. So just, you know, I like playing around with stuff and just to play around with some of these protocols. In this particular case, in an OpenStack cloud, HP's cloud deployment, just setting up a 6-node cluster. And what I did was on two out of the 6 nodes, I set up RabbitHub. On another 2 nodes, I had STOMP, and other 2 nodes, MQTT. Just to illustrate the point that, you know, not only can you publish and consume via different protocols, but again, it doesn't matter whether they're running on different cluster nodes. It's irrelevant. I could publish, you know, I could publish something into this node using AMQP and consume it out over here using MQTT. Doesn't matter. How many of you have set up Rabbit within a cloud environment? Okay, well that's good because there might be some useful information on the slide. But what you tend to find when you sort of say go into a cloud environment, be it EC2 or Amazon or whatever, or OpenStack, there are certain things you need to think about when you're setting up Rabbit within these environments. First of all, you've got to ensure that various relevant firewall ports are open. Okay, if you're setting up a cluster, certainly you need to do this. I mean, obviously port 5672, which is the default AMQP port, that needs to be open. If you want to use the RabbitMQ management plugin, which I suggest you probably do, then you need to ensure that port 15672 is open. If you're setting up a cluster and you want your endpoint mapper daemon to be able to do magical things and make sure your cluster works, you need to ensure that 4369 is open. And if you're using the other protocols and so forth there, the various port numbers that they use by default. Obviously all these port numbers are configurable, so these are just the defaults. Second point down here, from a clustering perspective, Erlang provides you with the ability to specify a port range that will be used for communication between clustered nodes. Most people, when they set up something in cloud, probably are a little reluctant to just open up every possible port number. So what you tend to need to do is to use these guys, inet, dist, listen, min, and max, to lock it down to maybe just one port or a couple of ports or whatever, so constrain the port range that's used for intra-cluster communication. And that's something you can specify in the RabbitMQ config. So setting up Rabbit within a cloud, there are a few things you've got to watch in order for it to work properly, and a few more things you've got to watch if you're going to actually do clustering. It's not a big deal. But, you know, if you haven't done it before, it's kind of easy to forget or miss one or other of these things. Just a note down here, you know, so this is more geared up towards the OpenStack kind of thing. I imagine this link is probably still alive. I helped out a guy there who's doing some stuff on EC2. Just talks about some of the stuff from an EC2 perspective. What sort of performance can I expect within a cloud environment? Well, I mean, generally speaking, to be honest, without even trying in a reasonably self-respecting sort of cloud environment, 20, 30, 40,000 messages a second, readily achievable, but I mean, it's kind of a dangerous thing to say, oh, well, we can do this many messages per second, because bear in mind that that depends on a large number of variables. Message size, for example, as illustrated by the graph there, has a huge impact on how fast you're going to start moving stuff around. And there are numerous other variables, like if you're doing persistent messaging and things like that, and obviously you're doing a lot more disk I/O, that has a performance impact. But the bottom line is, without really trying, you can achieve some pretty good levels of performance within a cloud environment, or indeed even on a good laptop. Keep in mind, if you're doing this multi-protocol stuff, that not all protocols are created equal. So if you look at, say, something like RabbitHub, you might think, well, that's kind of cute. I can publish a message using AMQP and I can consume that via HTTP. Keep in mind that, for example, HTTP is inherently request response. There's a bit more work that goes on there. It might not be able to keep up with what AMQP can push through. So not all protocols are created equal, both in terms of the use cases they support, but also in terms of those non-functional characteristics like performance. Some clouds also have this rather interesting habit, this one we used to hit on HP Cloud years ago, where there's actually bandwidth throttling. And so, you know, you might suddenly find that you've hit a wall on the maximum number of messages you can push through per second between nodes in a cloud environment. Possibly there's some vendor imposed throttle. The little blue box down here is actually quite an interesting paper where the guys at Pivotal worked with Google to get 1 million messages per second on Google Compute with Rabbit. I think it was, I can't remember the number of nodes, it was something on the order of a 30 node cluster, and it was a somewhat contrived test. You know, they were very careful about how they set it up so that there wasn't any disk I/O, and the routing was kept very simple, and so forth. But what I would say that paper does illustrate is it's a very good illustration, not necessarily of how you can rig some sort of benchmark or performance result, but it's a good illustration of how good Erlang is at doing this type of clustering. So what I want to do now, just briefly before we wrap up, is just, you know, a few little bits of code before people finally fall asleep. To just enough chatter from the Irishman. To just illustrate a few examples here of what I've been talking about in terms of being able to publish and consume via different protocols. So first up, simple example where we're going to publish a message via AMQP and we're going to consume that message via STOMP. So little piece of Erlang code that's going to publish a message into a queue called STOMP, and another little piece of Erlang code using the Erlang client I've identified over there in the URL. Little piece of Erlang code that's going to consume those messages that go into that queue via STOMP. So in this case we would be using the RabbitMQ STOMP plugin, obviously, and we can do all of that fairly simply. In this case, pretty much just a slight variation on the theme, but I can add a few more examples to illustrate more stuff here. So again, in this case, we're publishing a message, in this case, to the fan-out exchange. So if you remember how fan-out exchanges work, any queue that's bound to a fan-out exchange gets a copy of the message. So we're going to publish via AMQP into one of the default built-in fan-out exchanges. We're going to then have a Python consumer consuming from that exchange, and at the same time we can also have an Erlang STOMP consumer consuming from that exchange. So, you know, publishing via AMQP, consuming via AMQP, and also at the same time, because of the fan-out exchange, consuming via STOMP. We can then go and write a little bit of Ruby code, courtesy of Sinatra, and type a few simple curl commands and set up, following on, adding to the previous example, add an HTTP consumer. So this HTTP consumer again is going to consume from the AMQ.fanout exchange. Our message was published via AMQP into the fanout exchange. Our AMQP consumer, our STOMP consumer, and our HTTP consumer will all simultaneously get copies of that same message. What are we doing in this one? We're publishing via STOMP and HTTP. Nothing particularly fascinating here. So further extending our fan-out example, in addition to consuming messages via multiple protocols, we can also publish those messages via different protocols. Okay, so in this case we publish via STOMP to the AMQ.fanout exchange. Our HTTP RabbitHub-based consumer is going to get copies of that message, as indeed is our Python consumer, and so forth. And just the last one here with MQTT and consumed via STOMP. There are, you know, like I say, there are some limitations around here in terms of how the bindings and so forth, if you like, differ from one protocol to another. But the level of overlap is such that you can do a lot of fascinating scenarios involving multiple protocols like this. So, in summary, you can have lots of fun with different plugins and different message queuing protocols and come up with all sorts of fancy scenarios. A lot of the ability to do this, and I raced through the whole section, I apologise, I raced through the whole section on the boot steps and so forth, and how plugins get hooked into the Rabbit boot sequence and so forth. But the RabbitMQ plugin architecture allows you to extend the core functionality of Rabbit in many ways to achieve far more than you get with the base product. One of those ways being the ability to speak multiple messaging protocols. Now, it's a good piece of software, as I said before. You've got, with Rabbit, you've got good documentation, you've got good support, you've got good management and other operational tools and so forth, and everything's nice and so forth around open standards. And just to conclude and make me feel slightly homesick, you know, a picture of home. And there might be some hobbits wandering around. Any questions? No? For me or Eric?
What are the issues with federation, no, not federation, but running basically your clusters of RabbitMQ nodes, so even federation as well?
Yeah.
You know, I'm thinking of the split brains problem right here.
Yeah, I mean, as you probably know, the Rabbit guys have done a lot of work to try and minimise the impact of split brain, and I forget the names of them now, but when you set up the cluster, you can kind of say, well, I don't care if bad things happen. If you detect that a bad things happen, there's like, you know, shut down the nodes that are in the minority side of things and keep the majority over here running and so forth. None of them are really perfect, to be honest. It's an ongoing issue, and I think it's probably an area where there is room for improvement. I know that, you know, it's particularly a concern, as you kind of indicated, in a cloud environment, where possibly you're going across availability zones or something like that. And certainly in my experience, you know, with OpenStack, bad things can happen between availability zones. And message loss is a possibility. So the guys have done quite a lot to improve it. Is it perfect? No.
On one slide, you actually mentioned that clustering allowed people to add queues without reconfiguring the clients, but that's, I guess, that's also the case without clustering.
Okay, well, there's one point there is, which ties in also to what Francesco was saying to some degree, I suppose, is that, you know, when a client connects to a broker, it connects to a broker, right? It's a stateful connection with AMQP. So let's say the broker that you've connected to suddenly falls over in a screaming heap. Your client needs some mechanism to flick over to communicate with another broker. Now, you know, that's not necessarily a big deal, but what I would say is that some AMQP clients or some RabbitMQ clients are better geared up for that than others. Like, for example, with the Java client, you can have a list of brokers. With some of the other clients, you might have to write a little bit of code yourself to cater for that scenario. Another possibility is to do something like stick something like HA proxy or something similar out in front. So, you know, what's behind the scenes in terms of, say, a dozen or so brokers is irrelevant to your client. It's just connecting to HA proxy. But the problem you've got there, of course, is that your HA proxy suddenly becomes a single point of failure, right? So, yeah, how far do you want to go? No? All good?
Well, one more question. Given this level of flexibility in configuration and plugins and all this stuff, I assume you can easily shoot yourself in the leg. And are there any bad practices?
Oh, you can shoot yourself in just about every part of your anatomy, to be honest. The thing is with plugins, you can hook right into the bowels of Rabbit, right? Which is probably not a good thing to do unless you actually understand how all those bits work. Now, what the Rabbit guys did to kind of try and discourage that, so if you say look at something like the RabbitHub plugin, which was written fairly early in the history of RabbitMQ, and in part because of some of the stuff it needs to do, it really does plug right into the bowels of Rabbit. Later, subsequent plugins, what the Rabbit guys did was they tried to create sort of some abstraction layers, almost like some APIs built into Rabbit, and you know, would encourage you to use those. And there's much less potential for shooting yourself in the foot. But it doesn't get away from the fact that there's nothing to prevent you still from going in almost as low as you like. Are there best practices? Good code, good testing. I mean, I would, you know, reiterate the point that whilst Rabbit is a mature product, there may still be differences from one release to another that will potentially break some plugins. So if you've got a plugin and a new release of Rabbit comes out, don't take it for granted that everything's perfect. It may not be. Yeah, just think. Yeah.
Could you say a little bit about what kind of transactionalities sort of things exist?
You mean like, you know...
so, for example, could I like take a message off one queue and put it onto another queue and have
and that's atomic or whatever. Yeah, you know, Eric's written books on transaction processing, so I won't dare go into too much detail because I'll just get it wrong. So RabbitMQ doesn't support transactions, say, in an XA or two-phase commit type of sense. but it does support a comparable kind of transaction mechanism. Not as sophisticated or as good, but bear in mind that that's an AMQP thing. Protocols like STOMP, for example, don't support that. So that's another limitation where if you're trying to do transactional stuff in a multi-protocol world, no.
Yeah, it's probably, I think the trend, if we look at REST, is moving toward transactions as resources, where we're ending up having the programs manage more things than the system, more things compared to what they used to when the systems were doing more transactions. So everything tends to be a trade-off, and as we go into more of the modern environments where we have less stateful interactions to get the benefits of stateless paradigms, that means that transactionality is something that programmers are going to have to handle more of than in the past, when that could have been handled by the stateful interactions. All of the distributed two-phase commit protocols depended on stateful interactions. And we had a big debate about this in the OTS specification, OMG, for example, because in Corbett, well, you remember some of this, but in Corbett you had the capability, if you had a dropped connection, to reestablish it. But if you drop the connection and reestablish it, how do you know where your transaction is? You have to roll it back. So when you have introduce a dependency between your connection-oriented protocol and your transactions, you have some benefits, but at the same time, you're introducing a stateful connection for that purpose. And when you eliminate that, then you put the responsibility more back on the program for doing things like checking read before write to make sure that the consistency is there, or doing some logging of information so that you can come back if you're doing transactions as a resource and make sure things are done correctly. So I think it's one of those trade-offs, and I think that the more we look at RabbitMQ and other mechanisms as enablers for stateless types of communications through messaging, the more we're going to have to think about transactional consistencies as part of the program's job rather than the infrastructure's job.
I think that's fair comment.
And it's an excellent vehicle for creating more work for transaction experts, like our Newcomer.
He doesn't want any more work.
No, that's just in time.
All right. Okay, thank you very much.